I'm Joe Moysiuk, and I'm the curator of paleontology and geology at the Manitoba Museum. And today I'm happy to be talking to you a little bit about these minerals which glow in the dark. So I have 4 different minerals here. Here we have some selenite crystals. These are also known as the crystalline form of the mineral gypsum, which you can find in your drywall, for example. And these were actually found from the Red River floodway here in Winnipeg. We also have some crystals of calcite here. So calcite is the major mineral that makes up limestone. It's very common. And then on the left, we have 2 different specimens of the mineral fluoride. Now, fluoride is used in some industrial processes, and it's also known for being the mineral that was the namesake of the phenomenon called fluorescence, which is what we're going to be talking about today. If we turn the lights out, we'll see what all of these crystals have in common with each other. So under ultraviolet light, our selenite crystals glow sort of an eerie greenish yellow color. If we go over to our calcite crystal here, we can see it glows this nice pinkish red color. And then this fluoride crystal glows yellow under ultraviolet light, and the one here glows blue under ultraviolet light. So what's going on with these glowing minerals? Well, if we think back to our science classes from grade school, we remember that all matter is made up of tiny particles called atoms. And the atoms themselves are made up of smaller particles called protons, neutrons, and electrons. The protons and the neutrons stay in the nucleus of the atom, and the electrons are orbiting around the outside of the atom. And it turns out that what happens when we hit certain atoms with ultraviolet light is that there's just enough energy in that light to bump some of the electrons from a lower energy level of orbit up to a higher energy level. And when that happens, those electrons can't stay there forever because it's an unstable orbit for them. So they end up jumping back down to their lower energy level after some time. But when they jump back down, they release back some of the energy that they had absorbed from the ultraviolet light, and they release it in the form of light that's visible to us. Now, I can also talk to you a little bit about a related phenomenon to fluorescence, which is called phosphorescence. And this happens when the electrons take a little bit more time to jump back down from the higher energy level to the lower energy level. And so as they step back down to their original energy level, they release that visible light that we can see. And this gives a delayed effect for the glow-in-the-dark appearance of these minerals. This is the same effect that we see, for example, in glow-in-the-dark toys that you might have played with as a kid. And there are even some animals that exhibit fluorescence under ultraviolet light. So this phenomenon is widespread in the natural world. We have some fantastic examples of Manitoba minerals, like these selenites from the Red River floodway, in our Earth History Gallery, so please come and check them out.